Before, I do many educational videos that are available on my website, and one of them is called "Should Wood Be Used in a Turntable?" Should wood be used in a cartridge? Something like that. And I say no. Wood shouldn't be part of your cartridge or your toner. Why? Well, wood is soft. Wood is not rigid. But we know there are many cartridges made with wood bodies. Does that mean they're going to sound bad? No. I own one. It sounds wonderful. But it can never be optimal. It can't. It can sound great, but it will never be optimal. Why? Because it's too easily displaced. It's not rigid enough. It resonates wonderfully, which is why we make musical instruments out of it. And it doesn't belong, in my opinion. Remember, my goal is optimization, not sounds great. Okay? So I am not saying you've got bad sound if you have a wood cartridge. I just want to make that very clear. You are creating an opportunity to get less from the groove if you surround that critical area with less than rigid materials. Okay? So, and that's why you look at like there's one brand, a Japanese brand that's a storied brand that if you look at their cartridge line and you look at from least expensive to most expensive, you watch the rigidity of their cartridge bodies grow. So wood would then have no place in a tone arm either. It's just too lossy. And remember, we're talking about certainly single-digit nanometer range displacements that matter, that become part of our signal, that ultimately we can hear through speakers and headphones. Then let's look at so keep that in mind. Now, but that's not the only consideration. So you could have a tone arm that was built with perfectly rigid materials, but was otherwise poorly designed in one other area. So this isn't a roadmap to finding the best product. Keep these considerations in mind, and definitely keep in consideration this most important location. So let's talk about turntables a little bit. So turntables are a source of noise, right? Where are they? The motor. I did a video on how to inspect for turntable self-noise. It's just a basic video on using a stethoscope and how to start getting used to hearing the location of and the nature of and the amplitude, general amplitude of the turntable self-noise. And if you can hear it with a stethoscope, it will find its way to the cartridge, to the motor. It will find its way to your noise floor. Now, if you hear from the stethoscope this noise from your motor, and the best place to listen for it actually, is on your arm wand. Okay, sorry, not on your arm wand, on your arm board. If you hear noise there, does that mean things have gone bad? No, but monitor it over time. I mean, I've got quite nice table, and I can still hear something, but it's a relative. There's nothing quantitative about this. There's other ways to do it quantitatively. We're coming out with a product to be able to do that for you, to be able to understand the nature of the noise that both the bearing and the motor give off. So we want quiet apparatus. We want a quiet bearing that doesn't have bearing precession, for example. And stethoscope is your friend if you start going around listening to different tables. Put that right on the arm board, and you could also, when you do hear the noise, you could try listening just to the platter. So remove the belt, if it's a belt drive, just remove the belt from the platter and just listen to the platters spinning, so you can differentiate between motor and platter. All of this noise ends up as part of your noise floor. This is again the noise we don't know that we live with, and it's impossible to differentiate how it's actually deteriorating the performance. But with mechanical transcription, what you can generally expect, there are a few adjectives that I always hear from my clients who get cartridge analyses from me. As you improve the transcription process, you can expect more clarity, a better sense of focus, that you're seeing the instruments in 3D space, better separation of instruments, definitely it sounds more relaxed. It sounds more like music and less like you're listening to an electronically generated stereo system, right? It's faster transients. It just sounds more intelligible, and you start hearing performers that previously, performers in the music that previously you didn't really notice before. All of this, this is all an impact. All those adjectives and those descriptions I just used, where it is the effect of lowering the noise floor. So let me see what's next. Okay, so many people have heard me be very critical of the cartridge industry, and I am critical because I don't believe that cartridges today, the vast majority of them, are not built for optimal transcription. They're built for our ignorance. The cartridge building industry takes certain measures in some of their cartridge building designs to avoid being blamed for conditions that have nothing to do with them. And one of my favorite example, it has to do with a vertical tracking angle, which is the angle measured between a line between the stylus tip to the pivot point, the most important location, and the record. Now, in order to understand what's the optimal VTA that we should be playing at, again, you have to go back to cutter head design. And in the stereo era, by far, more records have been cut by Neumann or Neumann adjunct or Neumann similar cutter heads. And after lacquer springback, we're looking at 18 degrees. But the average cartridge on a level head shell under dynamic friction and standard tracking force is 9 degrees higher than that. And most people think, well, then I'll just lower my arm. Well, first of all, you're not going to get it 9 degrees down. You usually have about 1.5 plus or minus to play with. And that's not the right thing to do anyway. When you lower your arm, you're not hearing what it sounds like to change VTA. Not even close. It's not even remotely what it sounds like to change VTA. What you're hearing when you lower or raise your arm is the effect of multiple vector forces changing in the system. Those flood the sonic differentiation.